friends, engineers, and developers all. Welcome back to another episode of Embedded Executive. I'm Ken Briodagh, Editor-in-Chief of Embedded Computing Design, and we're so happy to have you all here at our very exciting podcast booth here at Embedded World 2026 in Nuremberg, Germany. We're so glad to be recording all these live podcasts that you've been watching and hopefully listening to. And right now, my guest, I'm so happy to be speaking with, once again, Jose Ruiz of AdaCore. Welcome, Jose.
Welcome. Nice to see you again.
Nice to see you too. How's the show been for you today?
Very good. It's very lively.
Yeah.
I see a lot of activity. It's
yeah,
good.
I think so. The energy seems really high.
It is.
This year. So, in case folks aren't familiar with AdaCore, can you tell us a little bit about the company and sort of what you guys do?
Yeah, of course. So AdaCore, it's a company that was founded like 30 years ago. We are focusing on embedded safety critical systems.
Sure.
That has been our thing from day one. We started with Ada because that's the name of the company. So we started with Ada, developing embedded safety critical systems in Ada, developing some expertise in different certification environments like DO 178 for avionics, railway, automotive. So
right.
that's our way through here. On our way, we have developed some expertise on other languages. We extended our offering initially to C and C++, because many people is developing on C and C++.
Yeah.
And a few years ago, let's say 5 years ago, we started introducing Rust within our offering with the same ideas.
Right.
Targeting certification, safety critical, embedded.
Well, I mean, that transitions beautifully because Rust is really becoming a first choice in these safety critical situations. The automotive industry is taking to it really, really in a big way, and it seems to be spreading everywhere. So can you tell me a little bit about how you guys have been developing with Rust and what you've been working on?
Yes, of course. So we started in the beginning. We started a bit tentatively, saying, "Okay, Rust is taking up. People is having interest into that."
Yeah.
So we started developing our know-how about Rust, and then we started to have customers' interest. Our customers, our traditional Ada C++ customers, saying, "Okay, we want to give it a try." We have, mostly young developers. They are really in love with Rust.
Yeah.
They come to these companies, kind of traditional companies, and say, "I want to develop in Rust."
Right.
So they started developing some proof of concept with Rust, and people started to get the feeling that Rust could be a good thing for safety critical software.
Yeah.
And then they started talking to us, saying, "What about if we wanted to take Rust to the next level?" Because one thing is to do a proof of concept, to give it a try, to play.
Yeah, but to scale is a
Yeah,
whole
exactly.
nother animal.
And then you need an ecosystem, you need support, you need a lot of things.
Yeah.
So we started to develop much more seriously our Rust offering, including everything ranging from obviously compilers, training, certification, tooling around. And that has been our, let's say, our way through Rust. That has been our experience.
Yeah.
Keep increasing the number of tools, keep increasing the number of things that we support. Recently, for example, we have developed in-house a BSP in Rust for a system of chip. So that's what the kind of things we are doing.
That's cool. I hadn't heard about that. That's nice.
We have a demo at our booth if you want to.
Well, maybe folks, if you're watching this from Embedded World, you should go by the booth and check out the demo.
Definitely.
So it's hard to believe as we're here at Embedded World to think, but I'm sure there are people out there watching who aren't familiar with Rust. What makes Rust so good for these safety critical situations? Why is that sort of becoming the direction people are talking about?
Yeah, if we have to pick one thing from Rust, the thing that most of the people would take is memory safety.
Sure.
Memory safety has been the key word for Rust. That has been the thing that people is saying about Rust. The idea is that people try to prevent the kind of memory issues that they have with C++, you have a pointer, you deallocate, but you still use it, so you may end up pointing to something that is a different thing today.
Yeah, yeah.
So Rust has an embedded mechanism to track all that and to avoid that at different levels. Most of the things are done statically, so you don't even have an exception at runtime. It's detected at compilation time, saying you shouldn't do that.
Well, right. You know, memory safety is becoming a bigger and bigger issue as there's more and more AI, more and more edge, more and more, all of this stuff. Obviously, memory could be a weak point. It could be a fail point. So memory safety is becoming mission critical in and of itself.
Oh, yes.
So that makes a lot of sense. And you guys have so much experience in working with Rust now and creating these tools for engineers out there to be working with Rust. For those folks who are watching and listening to this that want to get involved in Rust, where should they start? How should they get involved in working with it?
Yes, so Rust is I mean, it's rather easy to get into Rust. There is already some freely available compilers for Rust, so you can start giving it a try. Then, for example, we have put the BSP that we developed for a bare metal target. We put it into available for the community, so that's something that you can pick. So I think that you can get the community Rust to start playing with it.
Because that's fully open source.
Everything is open source. As even we have a commercial offering with Rust, but everything we do, we submit to the community. It's not something that we want. I mean, we don't even have an interest in keeping it in-house.
Right.
So we give it to the community. So everything we do, and there is already available tooling about it that is there.
Yeah.
I think the moment these projects get a bit more serious, when you need some kind of support. I mean, sometimes if you start a project today that is going to last for 10 years, you want to have the security of somebody saying, okay, if you have a problem with the compiler, I will fix it for you.
Yeah.
At that point is where they come to see us and say, can you help us?
That good partnership is really how you keep a product at scale that working.
Yeah.
That's awesome. Thank you so much, Jose. Really appreciate you taking the time to chat with me today.
Great to see you again.
Great to see you too. Folks out there who are watching and listening, make sure that you're subscribed. If you're viewing this on YouTube as a video podcast, thank you for joining us. Subscribe and hit the notifications bell so you never miss any of our programs, including our weekly In Case You Missed It news show, our Dev Kit Weekly, and of course, our podcasts like Embedded Executive and Embedded Insiders. I've been Ken Briodagh, Editor-in-Chief of Embedded Computing Design and your host. Once again, thank you so much, Jose, for joining me today, and thanks to AdaCore for being on the show.